Okay, good morning, everybody. In case you haven't noticed yet, there is an announcement on OnQ. Well, there's two. So this one was posted a couple of days ago. So there's the topics here. So the topics for the quiz go up to strings in car, so there's no floating point. There's a sample quiz here. When you look at it, you'll notice that it's relatively short, especially for a 90-minute quiz. It's basically timed for 60 minutes or 50 minutes. But we have 2 hours, so I just give you 90 minutes to do it. So you should be able to attempt every question with lots and lots of time. There's not actually that much to quiz you on. So there's only roughly 3 weeks of material. So basically, when you look at the quiz, you shouldn't be surprised if you think that the questions are quote unquote easy, right? They're not very hard. There are some places you have to be careful, but there's nothing extremely difficult on the quiz. And you shouldn't expect there to be anything unusual on the quiz either. Any questions about the quiz? All right. Today's lecture is, so I'm pretty sure I talked about memory models, memory diagrams. And so we're going to talk about creating classes, or start to talk about creating classes. And this will actually be the topic for the next several lectures. So this is an object-oriented programming course. So you need to know about this thing called the object model, right? So there's lots and lots of different object-oriented programming languages. Java is just one of them, right? Python is another one. For most of you, I would think that the object-oriented programming language you'd end up using is C++. But they all rely on this thing, or they all, when people talk about object-oriented programming in general, they often refer to this thing called the object model, right? So in C, which is a procedural type language, or a procedural programming type language, right? You break your program up into functions. You pass your data around by calling functions and passing data to and from the functions. In object-oriented programming, you decompose your program into a different structure, right? So you decompose it into interacting objects. The objects contain data, and the objects can interact with one another. So in this object model, there are 4 main elements. The fourth one we'll get to much later in the course. But the 3 that are important to us now are abstraction, encapsulation, and modularity. Right. Okay, so this guy named Grady Booch, he's a professor of computer science. I forget where. He's one of the, I guess, gurus of object-oriented programming. So he's one of these people who actually study object-oriented programming as part of his research. He's written a lot of the, I guess, foundational books on object-oriented programming. So this thing called abstraction. So he says, abstraction is one of the fundamental ways that we as humans cope with complexity. Right? So an abstraction denotes the essential characteristics of an object that distinguish it from all other kinds of objects, and thus provide crisply defined conceptual boundaries relative to the perspective of the viewer. So there's 2 important parts in that statement there. The first part is, well, I guess there's 3, right? So it's one of the ways that we deal with complexity. Abstraction denotes the essential characteristics of an object. All right, so you've seen a list, right? So we've all seen array lists so far in the course, right? So an array list is an abstraction, right? So it's an abstraction of a sequence of elements that you can access with an integer value, right? Now, we know how to use an array list now, right? So we've looked at the methods, we looked at the constructors, we know we've done some programming with them. And so you know that it's not very hard to use an array list, right? When you use the array list, you don't care how the array list works internally, right? So underneath the hood, I guess for a second-year student, it's a relatively complex, well, it's not that complex. It's a moderately complex data structure, right? But you don't need to know anything about the details of the data structure in order to use it, right? And so how is an array list an abstraction? Well, so what essential characteristics does an array list provide? Well, it's an ordered sequence of elements that you can get elements or remove elements using an index, right? And that's very different than other kinds of abstractions, right? Like a set where you can't get stuff by index. This last part here, relative to the perspective of the viewer, means something a little bit different. And so if you're creating your own abstractions, right? So for example, suppose you are programming a video game, right, where you drive a car around. right? And then one of the classes you might create is a car, right? And so you're going to provide an abstraction of a car in your video game, right? And so what do you care about for your car in your video game, right? Well, maybe what it looks like, how does it handle, right? Things like that. Right? Whereas if you were writing a program and you're trying to sell actual cars on the internet, then your abstraction would be very different, right? So that's what this relative to the perspective of the viewer means, right? You can provide different kinds of abstractions for the same thing, right? It just depends on who is using the, who's going to use your class in the, at the end of the day. Right. Okay, encapsulation. So encapsulation is the process of compartmentalizing the elements of an abstraction that constitute its structure and behavior. Right, so what he's trying to say here is that, look, if you have an abstraction of something, so we got an array list, right? Encapsulation is the process of taking that array list thing, right? So the data that's in it and the methods that operate on it and plunking it into one place, right? So compartmentalizing it, wrapping it up, right? Putting it in a capsule, right? These are all common terms that you see when you, people talk about object-oriented programming, right? And so you want to take all this stuff, put it into one place. Right? In C, you can sort of do the same thing. Right? So in C, if you were to implement your own data structure, right, you would compartmentalize it by creating a header file and a C source code file that provides functions for your data structure. Right? And finally, modularity, which is also related to encapsulation. Right? So modularity is the act of partitioning a program into individual components. Right? Now, why do you want to do this? It's because it helps reduce the complexity of the implementation. Right? So it's entirely possible to write a program like PowerPoint or Word or anything else, a web browser, right? And have everything in one file. Right? You can imagine what that might look like. Right? It would be a disaster to try to actually implement that, debug it, maintain it. Right? But if you break it up into individual parts, then it's much easier to implement, debug, and maintain the individual parts. Right? And so that's the idea behind modularity. Java has several different mechanisms for modularity. Right? C doesn't really have anything. C basically has you put stuff in a source code file and a header file, and that's more or less it. Right? In Java, you've got lots of different mechanisms for modularity. Right? You can create a class, right? Then you can create a package, and then you can create these things called modules. Right? So these all provide different levels of modularity. Okay, so what does a Java program look like? You've sort of seen, so in your labs, you've seen small Java programs, right? They're made up of one or more files, right? So you've got a bunch of Java files. In your labs, you've also got some text files that you read in sometimes and extra stuff. Right? So typically, there's one or more files. Inside each file, at the very top of each source code file, you might see a package name, right? You might not. I think in your labs, you have not seen a package name yet. Right? So at the top, you might see a package name. Then you'll see 0 or more import statements, right? So if your class needs to use some other class that's outside of the current package, it has to import that class. So we've seen that, right? You import Java util ArrayList to use ArrayList. And then typically, there's a single class inside of each file, right? And that's also the way that your labs have been structured. Now, inside that class, you know that there can be methods, right? But there's other stuff that you can put into a class as well. So we're going to start to put information into the class. Right? So how do you store information? Well, it's just variables, right? So there are these things in Java called fields, which are variables that live in a class. Right? You can have 0 or more of those. I guess that should be 0 or more. Right? Then you can have these things called constructors. Right? So we've used constructors. Right? So you use a constructor to make a new array list, for example. Right? Well, we haven't implemented them yet. So when we go to implement our own types, we're going to have to provide our own constructors. So we're going to provide 0 or more of those. Right? And then you know that their class typically has some methods in it. So there can be 0 or more methods in the class as well. Here's an example of a single Java class. Right? We don't actually care about the implementation. Right? So don't bother looking at the text. It's the structure here that's important. Right? So we've got one file, one Java file. This one happens to have a package declaration. right? It's got an import statement, right? Then we have a class, right? Inside the class, we've got a field, right? We have a field that's an array list. Then we have a constructor, and then we've got a bunch of methods, right? And so that's the way that most classes look like in a Java program, right? And typically, there will be more than one of these, right? And in a large program, there could literally be thousands or tens of thousands of classes. And it's actually much more complicated than this, right? So we don't have time in 12 weeks to talk about everything you can do in Java, but there's lots and lots and lots of other things that can appear in a class, right? And so this is just a partial list of stuff that can appear inside of a class. We'll only look at, what are we looking at here? We're going to look at this thing here. So eventually, you'll see a class inside of a class, right? Inside of classes, and so on and so on, right? But the rest of the stuff, we just don't have time to talk about in this course. If you want to know a little bit more about this stuff, it's easy enough to search, right? You can click on that link there if you want to see the official tutorial and look at a quick description of what these things are. Okay, so what is this thing called a package, right? So the packaging is one of the mechanisms that Java uses to organize classes in a program, right, or in a library. So packages are used to organize Java classes into these things called namespaces. And a namespace is nothing other than a container for names, right? And so the namespace also has a name, right? So you can think of a namespace, you can think of these namespaces as just being folders on your computer, right? That's actually the way that Java implements them, right? So just imagine you've got a directory a directory or folder on your computer that is the name of the package, right? Inside that folder, right, you know that you can put other folders, right? And so those would be other packages. Inside each one of those folders, you know you can put other folders. So those would be other packages, right? And that's all it is, right? It's just a way to organize your source code. So packages are used to organize related classes and interfaces into a single place, right? So if you look at the Java standard library, everything is in this package called Java. Right? That's why you use Java util.ArrayList or Java lang math or things like that. Right? Inside a package, you can place another package. So inside the Java package, there is this package called lang, util, io, and so on and so on and so on. Right? I don't know how many are in there. There's a few. Right? And so when you have a package inside of a package, the full name of the package is called the fully qualified name. Right? So the fully qualified name of the package lang is the name of the package that it's in, so Java, followed by a period, then followed by the name of the package. Right? So java.lang is the fully qualified package name of lang. Right? Java.util is the fully qualified package name of util. Right? Inside a package, you are allowed to place other packages and classes or interfaces. So inside Java lang, you'll find the class string and math and this thing called big O object. Right? So just like packages, classes also have fully qualified names. Right? So the fully qualified name of a class, like string, is just the fully qualified name of the package it's in, followed by .string. Right? So the fully qualified name of string is java.lang.string. And the reason we are using so one of the reasons why packages exist is because you want to make sure that your names in your program are unique, right? And this is a huge problem in C, because in C, C also has this problem, right? So the names in your C program have to be unique. When you start to have multiple C files in a program, you run into the problem where you can have a function in one file that has the same name as a function in another file. And now your program won't compile, well, it won't link. It'll compile, it probably won't link together into a single program. Right? And so packages are one of the mechanisms that Java uses to try to work around this problem. Right? So packages are supposed to ensure that fully qualified names are unique. Right? So what does that mean? It means that if you wanted to make your own string class for some reason, maybe you want a mutable string, for example. Right? Java strings are immutable. Maybe you're in your application, you're working with strings, and you have to change the letters in the strings all the time. So you make your own mutable string class. Right? You can place it inside your own package called your, right? and now its fully qualified name is your.string, right? The Java string class is java.lang.string, so they have two different names, which means you can use both of them in your program at the same time. You just have to use the fully qualified name for one of the two classes. Right? And so now this works just fine, right? I can use my string class here, and I can use the Java string class here, and everything works just fine. Now there's a problem. So the problem is that there's no central authority that looks at what people call their packages, right? So that's a problem. So that means that two different programmers can end up creating packages that all have the same name, and then they create a class that has the same name in the same package, and now you can't use their two classes together in the same program. Right? And so you still need some way to ensure that the fully qualified names are in fact unique. You can't do this in the language itself. You have to rely on a convention. Right? So there's this thing called a package naming convention. So when you create a package that's meant to be used for outside of your own organization, right? So in other words, you want to distribute your software and let other people use it, right? Then what you're supposed to do is you're supposed to take your organization's domain name and then reverse it, reverse the words in it, right? So the computing science domain name is cs.queensu.ca. So anybody in the computing science department that releases a Java software is supposed to put it in the package ca.queensu.cs. Domain names are unique because there is a central registry of domain names. Okay, but again, there's nothing in the language that requires you to do this, right? You name your packages whatever you want. Okay, so packages are one way that Java implements modularity, right? So we can separate our classes and put them into different packages, right? The packages can have nice descriptive names, so it becomes easier to understand the structure of a program. Okay, now what about classes? So a class is just an implementation of a type, right? So it's a user-defined type. For the most part, classes are used as a blueprint to make instances of the class, right? So in other words, the class is used as a blueprint to make an object. And I'll show you what I mean by that in a minute, in a couple of slides. Right? So why do we have objects? So every object gets its own copy of all of the non-static fields that are defined in the class. Right? And so what does that mean? It means every object has its own state, right? It's got its own set of variables that can be, it has its own set of variables, right? So each object has its own data. So the set of values that an object has stored in its variables is called its state. Right? So if I have a two-dimensional point called point 2, right, then you can make a bunch of different point 2 objects that all represent different two-dimensional points. Right? All right, so in this picture here, it's trying to show you a memory diagram of what happens after you run those 3 lines of code. Right? So what happens in this picture here is, right, we have a point 2 reference called p. Right? So there's p sitting right here. To assign a value to p, we call new, and then a constructor for point 2. Now, the first time you use a class in Java, that class gets loaded into memory somewhere. So when the compiler sees point 2p, right, it generates some code that causes the point 2 class to be loaded into memory. Right? So our point 2 class, we haven't seen the implementation yet, but there's a field called x and there's a field called y inside that class. Okay, now the new operator runs. So what does new do? New allocates memory for a point 2 object. How does it do it? It takes the class, copies the class, and plunks it down somewhere in memory. Right? So that's what we mean when we say the class is used as a blueprint for creating other objects. Right? You just take a copy of the class, plunk it down in memory. Right? So now this point 2 object has its own x and y field. Right? Now the constructor runs. Right? So this constructor sets the coordinates of the point 2 object to 1 and 2. Right? So that becomes 1 and that becomes 2. Right? And then finally, all of this returns the address of the object. Right? So the reference p stores the address of that newly created point 2 object. Right? So it's 600A. So remember, the A indicates that it's an address. Right? And then the same thing happens for q and r. New point 2, so new copies that class, plunks it down somewhere in memory. constructor runs, fills in x and y to -3 and 8. Right? And now you've got two different points having two different sets of coordinates. Right? So this point has its own state, that point has its own state, and the third point has its own state. So when you go to implement a class, most of the classes that we implement in this course are what are called value classes. Right? So a value class represents a value of some kind, right? Like a name, or a date, or a color, or a point, right? Or a vector, matrix, so on and so on and so forth. Right? So in the standard library, stuff like string, that's a value type class. Right? Integer, value type class. Right? Date represents times, so that's also a value type class. All right, so you know that inside of an object, there are some fields that represent the data belonging to that object. So when you go to implement a value type class, the first thing you have to ask yourself is, what data does each object need? Right? So you need to decide what fields have to go into the class. All right, so let's implement this 2D point class. Oh, let's start to do it. So I want to implement a two-dimensional point. It has a real x and y coordinate. Right? So how do we, what information do we need to store inside this point? Right? So the obvious implementation is you create a field for the x coordinate, you create a field for the y coordinate. Right? That's not the only choice, though. Right? You could create an array of length 2. Right? The first element of the array would be the x coordinate. The second element of the array would be the y coordinate. You can make a list of length 2, right? Where the first element is the x and the second element is y. There's probably not too many other sensible choices in this case. Right? But there's multiple choices. So there's usually no quote-unquote right answer. Right? Often this becomes a design problem. Right? Which as engineers is one of the things that we try to teach you in your undergraduate education. So how do you implement the class? Well, if you want to, you can put it in a package. Right? So if you have the source code for the course, the relevant package for the time being is this package right here. Right? How do you make the class? Well, it's just a class, so public class. You give it a name, so point 2 in this case. Right? Remember when you name a class, it should start with a capital letter. Right? You put in the braces for the body of the class, and now you add your fields. Right? So here I've got private double x and private double y. So on the fields and on the class, you have these things called access modifiers. Right? So remember, a public class just means that every other class can use the point 2 class. Right? Now, what about the fields? So the fields here are marked private. Right? And so private means that only the class point 2 can see the fields x and y directly. Right? So any class outside of point 2 doesn't know that the point 2 class has an x and y field. Inside the class point 2, right, we do know that there's a field called x and y. So that thing point 2 is what's called a top-level class. Right? It's a top-level class because it's not inside of another class. Right? So a top-level class can have either no access modifier or a public access modifier. Those are your only two choices for that access modifier there. Right? So it's either public or nothing. Right? Public means any other class can see the class. Right? No access modifier is what's called package private access. Right? So package private access means the class is visible only inside of its own package. Right? So if we struck the public here, right, then the class point 2 is only visible inside of that package, right, and exactly that package. Right? So it's not visible inside basics. If there's a sub-package of geometry, like, I don't know, XYZ, it would not be visible in XYZ. Right? It's only visible inside geometry. Right? You might ask yourself, why would you want to do this? But there is actually a reason why you might want a package private class. And we'll get to that later in the course. Right? So for now, all of our classes should be public. Now what about the fields? So our fields are marked private, and that means that the fields are only visible inside the class itself. Right? But you actually have 4 choices here. So you can have no access modifier on the field, you can have a protected access modifier, or you can have a public access modifier. So no access modifier is, again, package private. Classes inside the same package can see those fields directly. Right? So if we get rid of the private on these two fields here, and there's another class in geometry, right? Then that class can make a point to object called P, and then they could write P.x and P.y. Right? So they actually can see those fields, and they can access them directly by name. Protected means the same as package private, except visibility is granted to what these things called subclasses. So we'll talk about this several weeks from now. Right? So nothing is protected for the time being. Right? And finally, there's public. So public means the field is visible to all classes everywhere, as long as the class is also visible. Right? So that means if these were public, right, anybody can make a point to object called P, and then they could write P.x equals something and P.y equals something. Right? So they can access the fields directly by name. So generally, you have public fields only where you are defining a constant value that you want other people to use. So the safe rule of thumb, right? So this is the beginner's rule of thumb. As you become more and more competent at Java, you can start to relax this rule, right? But for the beginner's rule of thumb, your field should generally be private, unless the field represents a constant value that you want to be public, right? Like pi in the math class, right? It makes sense that the math class defines a value called pi, and that everybody ought to be able to use it. Right. Protected fields appear when we're using inheritance. So again, that's several weeks from now. Package private fields appear for another reason. And if I remember, I'll tell you what that reason is when we get to it. OK, so there's our point 2 class. Right? Simple so far, I hope. Right? What about implementing a class that counts? Right? So this counter class is just this thing that counts starting from 0 and goes up in increments of 1. Right? You might wonder why we'd have this class. Well, number one, it's easy to implement. Number two, it actually is useful for reasons that we'll see in a couple of lectures from now. All right, so I want this counter class. So, oh wait, that's a typo. Represent a counter. Right, so what fields do you need to represent a counter? Well, you just need the count. So that's pretty easy, right? So again, package declaration, right? Class declaration, field. Right, so here I'm going to use an int to represent the value of the counter. And it's going to be private because that's the rule of thumb that we're using right now. Oh yeah, that's pretty easy. What about a stopwatch? Right, so I want to implement a class where someone can simulate pressing a start button and simulate pressing a stop button. Right? They can also look at the watch and see how much time has elapsed since they pressed start. Right? If they press stop, then when they look at the watch, it tells you how much time elapsed between pressing start and stop. Right? So now the question is, well, how do I implement this? Right? So how would you implement this? So what information do you need in this case? Any ideas? Yeah, start time and a stop time, right? Not that hard. Now, there's one other thing you have to worry about, though. So if someone looks at the watch and you haven't pressed stop yet, there is no stop time. So you also need to know, is the watch running? Right? So that's easy. So how do we get the time now? Right? So there's a method called system.nanotime. Nanotime is the method that gives you the most precise available system time in nanoseconds, right? So 10 to the minus 9 seconds. Relative to some fixed but arbitrary time. So what that means is that nanotime of 0 doesn't actually mean anything, right? So whenever you call nanotime, it just gives you back some number, right? If you call it again, it gives you back another number. If you subtract the two numbers, that gives you the elapsed time, right? So fixed but arbitrary time. So it doesn't actually tell you what the start time is for nanotime. Right? But if you can get the start and stop, but if you call it twice, you get a stop time and a start time, you just take the difference, and that gives you the amount of time that's elapsed, right, in nanoseconds. So that's pretty easy. So it returns a long in this case. Right? So a long is just a bigger version of int. All right, so that's pretty straightforward then. So for the stopwatch class, we've got a start time, I've got a stop time. I'm calling it raw start time and raw stop time because these are in nanoseconds, and I want the watch to work in seconds. Then I want to know, is the watch running? So has the user pressed start but not pressed stop yet? Right? So that's just a Boolean field records whether or not the watch is actually running. Right? So also pretty straightforward, although I think most new programmers would not be able to get this in the first go. Okay, using our classes. So can we actually use our classes? There's nothing here, right? There's a class, there's some fields. There's no methods, there's no constructors. So do the classes actually work? And so the answer is somewhat surprisingly yes, they actually work. You just can't do a whole lot with them. So here you can go ahead and import all the, oops, sorry, that's big C counter. You can go ahead and import all the classes. There's a double period here, that's a mistake too. Right? You can import all the classes and you can actually make a point-to object, a counter object, and a stopwatch object. And that works just fine. Which is strange because we don't actually have a no argument constructor defined in the classes yet. All right, so we'll come back to this in a moment. So if we actually want these things to be usable, we now have to add some features to the classes. Right? So I want to add some methods so that people can actually use the classes to do something. We should add some constructors so that people can make their own point-to objects, their own stopwatch objects, and their own counter objects. Right? So we're back to this term encapsulation again. Right? So in object-oriented programming, the term encapsulation means bundling data and methods that use the data into a single unit. Right? So classes are one form of encapsulation in Java. Right? You take the fields, you take the methods and the constructors, plunk them all into a class, and you can imagine that the class is a capsule of stuff. Right? It's one bundle of stuff that you can use. All right, so the first thing we're going to want to do is implement a constructor. So the purpose of a constructor is to initialize the state of an object. Right? So it doesn't make a new object. Right? New is the thing that makes the object. A constructor initializes the state of the object. Right? So it's the thing that goes in and fills in the fields for a newly created object. Right? And so remember, when you implement your constructor, what you should do is you should look at all the fields in your class and then have the constructor assign a value to all the fields. Right? So when you implement your constructor, there are some relatively simple rules for now. Right? So the name of your constructor, same as the name of the class. Right? If you give it a different name, that's an error. Right? Your constructor does not return a value, right? Not even void. Right? So constructors are not methods. They look like methods, but they're not methods. Right? Depending on your constructor is allowed to have parameters, right? 0 or more. Okay, classes with no constructors. So our classes currently have no constructors. Right? We didn't define any. Because we didn't define any, the Java compiler silently inserts what's called a no argument constructor into the class for you. Right? So it doesn't tell you it's doing it, you just get one. Right? So every class has at least has a no argument constructor unless it defines its own constructors. Okay, so why is it called the no argument constructor? It has 0 parameters. That's why it's called the no argument constructor. Right? What's it supposed to do? It's supposed to initialize the state of a newly created object. How does it do it? Well, it's up to you. Right? You, as the designer of the class, it's your choice on what well-defined state means if someone doesn't tell you what values they want for the fields. Right? So what does the compiler-generated no argument constructor do? So it sets any primitive type numeric field to 0. Right? Any primitive type Boolean field gets set to false. Everything else gets set to null. Right? So if you have a reference field, then that gets set to null. So if we actually wanted to implement our own constructor explicitly, right, for point 2, so that the no argument constructor sets the coordinates to 0 and 0, it's easy to do. Right? It looks like that. Right? So the name of the constructor is the same as the name of the class. Right? No argument constructor, so it has 2 round brackets, nothing inside. You're allowed to have an access modifier here. What are your choices? Do I tell you somewhere? I don't remember what the choices are here. Public. I guess it's all four. So it's public, protected, no, package private, and private. So a public constructor means anybody can use this constructor. Right? Now I want to set x to 0 and I want to set y to 0. Right? But remember, this constructor is running on some object somewhere. Right? So really what you want to do is you want to set the x coordinate of that object to 0, and you need to set the y coordinate of that object to 0. Right? And that means the constructor needs to know what object is it setting the x and y coordinates for. Right? So the name of the object that's the coordinates are being set for, in Java, it's the keyword this. Right? So inside of a constructor, the keyword this is a reference to the object that's currently being initialized. Right? You don't have to define or declare the reference this yourself. Right? You get it for free in Java. Right? So this dot x means set the x coordinate of the current object, the object that's being initialized, to 0. Right? This dot y means set the y coordinate of the object that's currently being initialized to 0. Right? Now if you've programmed in Java before, you probably know you don't actually have to write this x and this y. Right? If you just write x and y inside of this method, inside of this constructor, then the compiler will automatically insert this dot for you. Right? So in other words, if you just write x equals 0 and y equals 0, it will work. Inside all of the code that I provide for you, it's always this dot and always this y. It's always this dot in front of the field name, and that's to remind you that there actually is an object, right, whose field x is being set. Right? So whenever I use a field, it's always got this dot in front of it. Right? Any questions so far? Yes?
How does it know it's a constructor versus a class?
How does it know it's a constructor versus a class?
It's like when you're compiling.
When you're compiling, how does it know? So, how does it know it's a constructor rather than a class? Is it because they have the same name? Is that the problem? Is that what's? How does it know that it's a constructor? So, in part, no. I mean, I'm just trying to decide the best way to answer the question. So, in part, it's the context in which you are writing, the context in which the code appears. Right. So back here, is there an example? Yes, right here. Okay. So here, you're declaring a variable of type you're declaring a variable p of type 0.2. Right. So in this case, because you're declaring a variable, right? So given the context, right? The compiler knows this must be the class 0.2. Right. Over here, right? Because it's after new, right? And it's got round brackets on it, right? It knows that this must be the constructor call. Right. So in I'm not going to say all. In many programming languages, the meaning of something depends on the context in which it's written, right? Which actually complicates writing the compiler, but that's a whole other story. Okay, so let's, sorry, question? Yes, sorry.
Yeah, I was just going to ask, if we initialize a private field with a constructor,
yeah,
that just means we can't access it again after the constructor.
That's a good question. Yes, so far everything I told, so for example, when you call a method, so far I've told you all methods are static, right? With a static method, you always use the name of the class to call the method, right? That field is not static, right? So it's private double x, right? There's no static modifier there, right? So to access this field, you need an object to access this field, right? So you're not allowed to write 0.2.x in this case. So I need an object reference. So I need a variable p that's of type 0.2, right? Now, can I write p.x? And the answer is no, because it's private. If it was public, somebody else could write p.x. Right? Now, inside the class, right, I can write whatever I want .x. Right? This .x, if I have an object of of type 0.2, I can write p.x. Because I'm inside the class. I have direct access to the field. Sorry, just let me check the time quick. Okay. Okay, so what happens when you write that one line of code, right? So in Java, it turns out a whole bunch of stuff happens, right? Which C programmers hate, right? Because in C, you basically say on every line, you're saying what you want to actually happen, right? When this happens, a whole sequence of things. When you write this line of code, a whole sequence of things happen that are hidden from the programmer, right? So on that one line of code, we're declaring a variable called p. So a variable called p appears somewhere in memory. Right? Step 1. Step 2, new gets called. Right? There's actually a step missing here, but anyway. Step 2, new gets called. So what does new do? It allocates memory for a point2 object. How does it do it? It copies the point2 class into memory somewhere. Right? So now, right, some memory gets allocated. So for a C programmer, malloc gets called. Right? And that object gets created somewhere in memory. Right? Fields x and y automatically appear. Right? Step 3, the point2 constructor now starts to run. Right? So when a constructor or a method runs, right, it has to run somewhere in memory. Right? When anything runs on your computer, it runs somewhere in memory. Right? So somewhere, the constructor pops up in memory. Right? It doesn't matter where, for our purposes. Right? But somewhere in memory, the constructor's running. Okay, when that constructor runs, it gets the address of the newly created object. Right? So it gets the address 600 passed to it as the variable called this. Right? And so that's how all of this works. Right? So new makes the object, returns the address to the constructor, or it doesn't return. It sends the address to the constructor, so that the constructor knows when it runs, it has to fill in that x and that y. Right? So the constructor starts to run. It sets this x to 0 and this y to 0. Right? So just follow the reference. Right? So this x up to here, so that gets set to 0, and then this y gets set to 0, like that. Right? And now the value of p is set to the memory address of the constructed object. Right? So after the constructor finishes running, new finishes running, new returns the address back to p. Right? So that address 600 now gets passed back and assigned to the value p. Right? And so a whole sequence of events is initiated by that one little line there. Right? Yeah, so if this was a C program, right, and you were doing this would be a pointer. You'd have to call malloc. Right? After calling malloc and checking that the return value from malloc is not null, right, now you can go in and set x and y, right, and then you'd be done. Right? And so that one line hides all of the memory allocation that would normally happen in a C program. Right? Let's stop there, I think. Quarter after? It's probably quarter after now. Yeah, so let's stop there. And